From our notes, we should remember that the absolute value of x is equal to x if x is already positive. And it'll be the opposite of x if x is negative. So remembering this basic definition will help us with the rest of these problems, because it's the absolute value of whatever's inside is going to equal whatever's inside if whatever inside is positive, and the opposite of whatever's inside if whatever's inside is negative. So let's try with the next one. For the absolute value of 2x, that'll be 2x if 2x is already positive, or the opposite of 2x if that 2x is negative. Now we can clean this up a little bit. Not over here. These guys are already simplified, but each of these inequalities could be simplified a little bit more. So we could rewrite this piecewise definition as 2x if, now for this inequality, divide both sides by 2, we'll have x being greater than or equal to 0. The other part would be negative 2x if, and once again dividing by 2 will leave us with x being less than 0. For part C, when we want to define the absolute value of negative x, don't let the negative on the inside fool you. Just go through the way that we've gone through before. The absolute value of something is that something if that something is positive. Or it will be the opposite of that something if that something is negative. Now, clean up everything we can. Negative x will stay negative x. But for the right side, when we have negative x being greater than or equal to 0, we'll have to divide both sides by negative 1, which we know for solving inequalities, when we divide by a negative number, we have to switch the inequality. Down on the bottom, the opposite of negative x is now positive x, and when we divide by negative 1, x will be greater than 0. For part D, the absolute value of x minus 3, that's going to be x minus 3, or the opposite of x minus 3, if x minus 3 is positive or negative. Now simplify every part that you can. X minus 3 is already simplified, and negative x minus 3, we could distribute the negative inside to be negative x plus 3. But now, on the right side over here, we have to add 3 to both sides. So instead of x minus 3 being greater than 0, x will be greater than or equal to positive 3. Instead of x minus 3 being less than 0, x will be less than 3. Same thing with x plus 9. It's either going to be x plus 9 or the opposite of x plus 9. It'll be x plus 9 if x plus 9 is positive, and it'll be the opposite of x plus 9 if x plus 9 is negative. Now simplify every part that you can. X plus 9 can't be simplified. We can distribute the negative into negative x minus 9. And then for the right side, we have to subtract 9 from both sides. So x will be greater than or equal to negative 9, and x will be less than negative 9. This is where it gets a little bit tricky. When we have the absolute value of x minus 3, with that minus 3 outside of the absolute value, remember with the piecewise definition, it is whatever is inside the absolute value and the opposite of whatever is inside the absolute value. So for both pieces, that minus 3 is going to stay the same outside of that absolute value piece. The conditions are going to be if what is inside the absolute value, just the x, is positive or negative. And now all the pieces here are simplified. Last one, absolute value of x plus 9. What's inside and the opposite of what's inside. These plus 9s are both outside of that absolute value, so they don't change. And then our two conditions, if what is inside is greater than or equal to 0, and if what's inside is less than 0.